All right, hello everyone. My name is Salvador Iniguez,
My name is Nicholas Iniguez.
and we are the Vanderlip Gang. The project we decided to go with is a passcode door lock, and the reason for why is because they're a very popular technology used to establish security in private and public buildings for homeowners and for even automobiles.
First, we will go over the hardware that we used, and then we will walk you through the code that we used for the project, and then we will show you guys a demonstration of our project. This is an Arduino Uno. It is a microcontroller. It acts as the brain of the project. Uh, this is the 4x4 keypad. It's used to input analog data to the Arduino. This is a 16 by 2 LCD display. It gets sent digital data from the Arduino and displays characters up to 16 by 2. This is the pin diagram for the 16 by 2 LCD display. As you can see, the first and 16th pin are ground. The second and 15th are power. Pins 7 through 14 receive data. We used all the pins except for pins 7 through 10. This is a 9-volt power supply. It's used to power the Arduino. This is a 12-volt lock solenoid. When it is supplied power, it disengages. This is the 12-volt power supply. It powers the lock solenoid itself. And when it's given the signal, it allows the lock solenoid to disengage. This is the breadboard. It's used to connect components to and from the Arduino. These are really convenient in projects like this because you don't need to solder. This is a buzzer. The buzzer beeps whenever a button is pressed on the keypad or whenever a password is entered correctly or incorrectly. This is an NPN TIP 120 transistor. This transistor acts as our relay for the 12-volt lock solenoid. This is a USB type AB cord. This cord is used to transfer code to the Arduino. These are jumper wires. They're used to connect components to the breadboard or to the Arduino. And this is our project fully assembled and functioning. As you can see the lock solenoid, the keypad, the breadboard, the LCD display, and the Arduino. Now we will cover the code and walk you through it.
All right, you guys, here's the C code that we ran for our project. If we look to the very top, we've got multiple header files included, such as the keypad.h file, the liquid crystal, and the EEPROM. And basically, we had to declare these files in order to have control of the keypad, the LCD, and the EEPROM on the actual Arduino. And the lines of code following the inclusion of the header files are just some lines of code that, such as the character arrays that store the password that you enter into the keypad. Then after that, we've got the lines of code following are the character arrays that actually like store the keys on on the keypad. All right, moving on, we're going to start with the void setup program. And basically, this program it initializes the LCD and it starts to output text onto the actual LCD itself. The text that gets displayed first is a message that says electronic keypad lock. And after this message gets displayed for a few seconds, it disappears, it gets cleared, and then that's when the user is prompted to enter the PIN. And while it says enter PIN, the user is also prompted to enter the PIN, and the this is when the keypad lock is able to actually read input from the LCD itself, and it's stored in the EEPROM. Oh, and before we move on, the pin mode function that we use within this function basically allows us to program pins on the Arduino to output, and that's basically what we did. And with that said, we're going to move on to the void loop function. Okay, so now we're in the void loop function, and basically this is the program or the part of the program to where like when you enter the pin on the keypad, the 4 digits that get stored it gets read into the EEPROM and it gets compared to the stored correct password, which by default is 1234. If the correct pin is entered, then a message gets displayed that says pin accepted, and a signal is sent to the transistor. And when the transistor receives that signal, it basically allows power to flow to the door or to the lock solenoid, which retracts the lock itself. Now, also after the correct pin is entered, you're also on the LCD itself. You see a message that says "press pound to change." And if you press the pound sign, a message pops up telling you to enter the pin, and which is the user's prompt to enter the current pin. Because of course you have to enter the correct password before you can actually change the pin. Now this only happens if you enter the correct password. Create an if-else statement to have different conditions for whether or not the correct password is entered correctly or incorrectly. So what I just explained to you right there in this first if statement is what happens if the correct password is entered. Now we're going to move on to what happens when you enter the incorrect password, which takes place in the else bracket of the code of this particular if-else statement. So what happens when you enter the incorrect password is the buzzer goes off, and it goes off for a few seconds, and the message gets cleared and it says access denied. Now, what's in the if and the else statement is like which or in terms of the project itself is when you enter the correct or incorrect password, you're still prompted the option to change the pin, which as you can see, it says press pin to change. And like I said, in whether or not you enter the correct password or the wrong password, you have the option to change the pin or to press pound to change the current pin. And with that said, that brings us to the void change function, which I'm going to briefly explain. So the void change function, this function gets brought in if you press the pound sign to change the pin. So when you press pound, a message gets displayed on the LCD that says current pin. And this is basically a prompt to the user to start entering the current pin. Now when you enter a 4-digit pin, it compares what you entered to the correct password. Now if you enter the incorrect password, what happens is the LCD displays wrong pin. So of course, what happens is it sends you back to the main screen and you have to press pound again to re-enter the screen that prompts you to re-enter the password. Now, if you enter the pin correctly, a new message gets displayed on the LCD that says enter new pin. And what happens here is you basically enter what you want the new password to be. And after you enter the new pin, you basically just re-enter it one more time, which the LCD prompts you to do so. Then after you do that, the LCD display is done. And that's how you know you've entered the correct new password. And once you've done that, you've officially changed the current password. And this last bit of code is the void beep function. Now all this does is just simply it sends a signal to the buzzer to make a beep noise. Now whenever you press a key on the keypad, it makes a very short beep noise to indicate that you've actually pressed a button on the keypad. And what it also does is that when you enter the incorrect password, it emits a long beep noise that's about 3 or 4 seconds long. And when you enter the correct password, it emits a shorter beep that's about a second long. And that's pretty much it for the beep function. And now we're going to move on to the demonstration portion of the project. Alright, so this is the demonstration for our project. We're going to start by supplying power to it. Okay, power is supplied. The initial startup message says electronic keypad lock. That displayed, and now we're prompted to enter the pin. So as we said before, 1234 is the default password. However, before we test the correct password, we're going to make sure that it just doesn't accept any password like whatever. So we're going to enter another password other than 1234. Okay, that doesn't work. So now we're going to try a different pin. So we tried 4, 5, 6, 7, and that doesn't work. So now we're going to try the correct pin, which is 1234. Okay, that was the correct password. It was accepted. We're prompted to enter a new pin by pressing pound, and the lock retracts again and goes back to the locked position after a few seconds. So now we're going to press the pound sign to change the current password. Current password 1234. Pin was accepted, so now we're going to enter the new pin. So now 0000 is the new pin. So now we're going to try that right now to see if that works. First, we're going to try 1, 2, 3, 4 to verify that the old password does not work. Okay, access denied. It didn't work. So we're prompted to change the password again, but we're going to verify that the new password works. Okay, the PIN was accepted and the lock retracted. Okay, there we go. So it worked properly. The lock solenoid is back to its locked position. And that is it for the demonstration. And just to verify, we're going to show that the cord running on the bottom right, all it is just a source of power and nothing more. Right? The only thing jutting out from the container itself is the power cord right there, the keypad, the LCD right here, and the lock on the bottom left. Right? No code's being loaded into it real time. All the code that was run on here was already preloaded onto it from the Arduino IDE using the USB Type AB cord. Now this concludes the demonstration, and if there are any questions or comments, then please feel free to ask them right now.